Welcome back to Mr. Oni channel. We will do for the unit of metals. Let's go, Oni. Okay, in your textbook, this is unit 13 and 14. The first one, this is the physical properties of metals. The thing that I put is the important one. All metals are strong. All metals are malleable. It means if you hit it, it will not, if only will change the shape, but not brittle. Brittle is mean it will break. Yeah, my label in bahasa Indonesia is called penyok. Okay, and then it's ductile. Ductile mean you can pull it into wire. So metal is ductile because the shape of the metal is look like here in the corner. This is the positive one is the metal ion, and the electron is forming the seed of electron. Yeah. So therefore, when you hit that metal, the formation of this positive ion just change. And when you pull it by using machine, of course, not by using your hand, it will be slip over each other and make it into a line up like that. And then metal, if you hit the metal, it will make sonorous, and then it's shiny, but actually not all metal always shiny. And then it's good conductor for electrical. Why? Because this electron is free. It can move freely, so it can conduct electricity. Because electricity is the movement of electron, so the electron can move toward this layer of metals. And then it's good conductor of it because this is very, the distance is very short. So therefore they can conduct a heat also. And then it's have high melting point and high boiling point. Why? Because it's very dense. So therefore you will be very difficult to melt it and to boil it. It requires a lot of heat because this is also, there is metallic bonding between one ions of metal and others, and the sea of electron help the metallic bonding also. And then it has high density, so therefore it have high melting point and boiling point. This is the example of metals. And then when metal is react with acid, it will produce hydrogen. I use magnesium, yeah, plus HCl, magnesium, Cl2. Why there is 2? Because magnesium is 2 plus H2. Yeah, this is not balanced yet. Yeah, we can do the balancing equation here by put 2 here. Okay, and then this will produce hydrogen. This hydrogen will make bubblings inside the test tube. When you collect the hydrogen and lighting spleen, glowing spleen here, it will produce pop sound. Okay, that is how metal with acid. But actually, is there any metal will react with acid? No, because some metal that's very unreactive will not react with acid. Okay, and then metal will react with oxygen to form base oxygen, and the base oxides, the base oxide, metal will react with oxygen to form base oxide. This base oxide can react in neutralization process to make with acid to form. But okay, let's go here. Okay, for example, if I use calcium here, if I have calcium, I react it with oxygen. Yeah, This will make calcium oxide. Okay, this is not balanced yet. Yes, I know. So you have to balance it. This will be 2 calcium CaO here. And then neutralization process. Okay, this is base oxide. All metal will make base oxide when it reacts with oxygen. Okay, this base oxide can be neutralized. For example, I use this one. This is acid, sulfuric acid. This also acid, hydrochloric acid. Okay, this will be form neutralization. Okay, the neutralization will produce salt. This is the salt plus water. Yeah, neutralization process produce salt plus water. This is base oxide. This is acid. Okay, so here is salt and water, and this one is salt and hydrogen. Okay, the tendency of the metal is always produce positive ions. The more the reactive of the metals will produce more positive ion. Will be tend to produce more positive. This is the reactivity series for the videos, YouTube's. You can play it by yourself. I have already included in your PowerPoint, so you can use it. This is the mnemonics. Please stop calling me a cute zebra. I like her called smart code. Yeah, this is to help you to remember the reactivity series. Okay, and then how the metal can react with water. Okay, the more reactive the metal, it can react with water without any steam, any heat. Heat help the reaction to be processed, to be occur. Why? Because when you heat up a chemical in during reaction, it will give energy. Later we will study it in chemical energetics later on. Okay, so if the metal very reactive, it doesn't need any heat. Cold water is enough to make it react with. Okay, the strongest metal is potassium, the reactive one, the most reactive one. And then this potassium will react with cold water to produce potassium hydroxide and hydrogen gas. So you can also they said you can also check it by using the glowing split. It will produce pop sound. Potassium, sodium, calcium, it will produce hydroxide. Why hydroxide? It can react with cold water and really strong, really reactive. So therefore, they tend to make positive ions, very positive one, and can pull the hydroxide into their self. Okay, magnesium and zinc and iron will react only with steam. Even though the magnesium can react with cold water, but very slowly. So therefore, they make oxide, not hydroxide, because it's not enough strength to pull hydroxide. They only pull the oxygen. Ammonium is a little bit anomalous because ammonium tend to react with oxygen in the air to form a layer of Al2 ammonium oxide, which is very unreactive. So therefore no reaction happen. Lead, copper, silver, gold cannot react with cold water or steam because it's very unreactive. Okay, metal can react with hydrogen acids when the hydrogen is below them in the reactivity series. Why? Because the metal will take the most of the hydrogen. For example, only is hydrogen, only held this marker here, chloride, for example. So this is hydrochloric acid, honey acid. You are hydrogen now, okay? I will take the spouse of honey, the pen that on by the honey, okay? And must be strongest than honey. So if honey is less reactive than me as hydrogen, and we can take it, okay? So all metal that above hydrogen can take the spouse of the hydrogen from the hydrogen, yeah, can displace it, can take it, okay? However, if hydrochloric acid, this one, only hydrogen, chloride is the pen, is only is stronger, is more reactive. For example, I am cold, I cannot take it because only is stronger, more reactive, not stronger but more reactive. Okay, so potassium and sodium is the most reactive metals in the world, in the earth. It's very reactive, and it will pull the spoils of the hydrogen very rapidly. It's very dangerous. It's very exothermic. It's giving off heat very much, and it's called Gauss explosion. Don't do it at all. Calcium, magnesium, aluminum will produce salts and hydrogen during the reaction. Why it produces hydrogen? For example, only is hydrogen. I take the chloride from here. I will become salt because I'm metals, ionic compound with non-metals making salt. Only himself will be alone and will pairing with other ionic hydrogen gas. That is, Oni is not gas actually. He is flashy. No. Okay, so therefore, this one, it will react like this only for the reactive metal. Yeah, more reactive metal than hydrogen. It will produce salt and hydrogen gas. Okay, but if the metal is less reactive than hydrogen, it will not happen. For example, silver plus HCl, sorry, not. It will not happen. Why? Because silver is less reactive than hydrogen. Okay? This is the redox reaction. So if I do this one, the redox one, so I will only see for the Mg and hydrogen, the chloride will remain the same, the OSN, so I will not take account of it. So this one is 0 because it's free element. The hydrogen here is +1. This is +2. Why +2? Because magnesium is +2, group 2. This is 0. Okay, so therefore the half reaction looks like here's one. Okay, magnesium will react into Mg +2. In the half reaction, you always have to write the electron to balance it, 2 electron. And then the other half reaction is 2H plus here and become H2. In this case, you have to add the electron in the left side here. So therefore, I can conclude this one is reduction. This one is oxidation. The strongest the metal, it will make more, it will be prone to be positive ion more. Okay, okay, like that. You can do it by yourself. Actually, this is very easy. And then, how about the carbon? Why carbon is adding into the reactivity series? Hydrogen and carbon is adding because it can be a comparison. And actually, if we add carbon, we can see whether the metal can be extracted by using carbon or not. The more reactive metal than carbon cannot be extracted by using carbon. You should use electrolysis. You should use electricity to separate it from the earth. However, the less reactive metals than carbon can be extracted by using carbon. For example, this is the example, zinc. Zinc is less reactive than carbon, so therefore it can be extracted from the ores that contain oxide or other ionic compound of zinc inside it by using carbon, because carbon is stronger and can steal those spores of the zinc. For example, honey becomes zinc. Honey is zinc oxide and carbon. I will purify honey into only zinc. I will steal the oxygen from honey. That is the reaction with carbon. It's actually a little bit the same with the hydrogen. In this case, all reaction with hydrogen, carbon, and also with displacement with other metals is actually like the stronger metal will, the more reactive metal will still dispose or the pair of the other metal, which is less reactive. Yeah, this is oxidation and reduction also, the reaction, yeah. And then how about with the other metal? For example, sodium is more reactive than calcium. You can see here, sodium and calcium. Yeah. So therefore, no reaction between sodium oxide, which is very strong, and calcium. I will still this only wife here, oxygen. I cannot steal it because Oni is very strong. He hold his wife very, very strict. I cannot steal it. Okay. However, the calcium oxide Oni is sodium, Oni can steal my spouse, my husband, like to become gay. No, for sure not. Okay, like that. Yeah. So the strongest metal can react with the less reactive metal. For example, case of this one, I have list of metal A, B, and C. One, I told you that A can displace C salt, C can displace B salt, and then I ask you to make the relativity list of ABC. I will name ABC actually. It's not important. Okay, so therefore I can put it here. A can displace salt. C. So therefore A is strongest or more reactive than C. Okay. C can displace B salt. So therefore C is more reactive than B. So this is the reactivity series from the most reactive to the left reactive. Okay. For example, I love example. Okay, salt, it means, for example, I have A and C nitrate. Can it will be displaced? Yes, for sure. So this one will be make ANO3 plus C. However, if I return it, for example, I have BCl plus C. Can it happen? Yes, because B is less reactive than C. So we will have CCl, C chloride plus B. This is not carbon, yeah. This is only the example of the reactive, the displacement one. Okay. However, if we have A and B, yeah. For example, I have, for example, A sulfate plus C. Will it happen? No, because A is more reactive than C, like that one. So you have to mention one by one from this reaction. I place hydrogen. So I said that hydrogen is below C and carbon is above C. How we can do the reactivity series now? Okay, so this one carbon, this one hydrogen. Okay, one more example. If I react V with HCl, will it happen? No, because hydrogen is stronger. Okay, but however, if I react A with HCl, with hydrochloric acid, will it happen? Yes, for sure. So it will be make salt and hydrogen gas. Okay, this is for hydrogen. How about with carbon? I will extract A with carbon. Will it happen? For example, it will be from in the ore, it will be from A oxide. I will add C here. Will it happen? No, because carbon is more reactive than A. How about if I will extract C with carbon? Will it happen? This one is carbon. Okay, yes, it will happen. It will make carbon monoxide or carbon dioxide plus C. Or carbon dioxide plus C. I made mistake by using an example of C. Why this happen? Actually, because the more reactive metal is done to make positive ion. It's more readily to make positive ion. Okay, so this is actually this one is called the half reaction. Yeah, this one is half reaction. Yeah, A. And this one is called ionic reaction. Okay, like okay, for example, if a metal displays other metals, we can see in the reactivity series, for example, iron 2 oxide and then plus sodium. For example, I have iron 2 oxide plus sodium. This reaction will be happen because with sodium is stronger. It will make sodium oxide plus iron. Okay, so if this is the word equation, I will do the chemical equation. So this is FaO. Why O? Because this is 2. Oxygen is 2 also. This is an sodium. Okay, this is will make an N2O because the oxygen is 2, sodium is plus 1, and then this is will make iron. Okay, this one is the half reaction. Yeah, 0, free element. This one is plus 1, min 2, and this one is 0. Okay, so the half reaction, I will do it here, is this one. For the iron first, Fa plus 2 will become Fa. So this one, we need to add 2 electron, yeah, like usual. This is the reduction process. And then the other one, oxygen, we will not see it because the OSN is always the same. Sodium, it will become sodium 2 sodium positive because there is sorry, there is 2 sodium plus this one charge is 2 electron, 2 positive 2. We have to add 2 electron here. This is the oxidation. To make the ionic reaction, you have to cross all the electron. So when I want to make the ionic reaction here, I will cross this one. And this is the ionic reaction. Plus sodium. So therefore, A plus 2Na plus. Okay, this is the ionic reaction. Okay. And then next. This is the connection between the extraction of metal and the reactivity. The more reactive metal, very reactive above the carbon, only can be extracted by using electrolysis. When if it's less reactive than carbon, you can use the carbon or heat it with carbon or carbon monoxide to extract it. Why need heat? Because heat provides energy. Okay. However, the very unreactive metal, silver, gold, platinum, is occur naturally with in the pure form, and we don't need any chemical reaction to extract it, or is the name of the type of metal that we can extract it. Okay, this is the extraction of metal. The first one, we only learn 2 of it, iron and aluminum. Remember, the name of the ore of the iron 2 is hematite. This is actually iron 2. Okay, it's mainly contain Fa2O3, and you need to add calcium carbonate, limestone, and coke. Coke is coal, batu bara in bahasa, or arang, looks like arang lah, and pure carbon. That is pure carbon. So there is 3 material that necessary for the extraction of the iron. This process is called blast furnace. So we add the iron ore, hematite here, and the coal, and then we add air from above here. So therefore, the air is contain oxygen. So the first process is carbon. We react with oxygen. Yeah, carbon will be heat up with oxygen. It will produce carbon dioxide. This one is called combustion. Anything that you burn with oxygen is called combustion. This will produce CO2. The CO2 will react with other carbon that we add from in the form of coke here, and then it will produce carbon monoxide. This is redox reaction. Actually, this one will happen in lower this one in this temperature, yeah, around 500, and then the carbon monoxide will be used to reduce Fa2O3, yeah, iron 2 oxide. This is the reduction oxidation process. So in this case, carbon monoxide here, if you can see here, will be oxidized into carbon dioxide, while when iron 2 oxide will be reduced into air. This is actually the reaction that purified the hematite. Okay. However, other pollutant, other non unwanted substance in the iron ore is calcium is this one, silicon dioxide. We need to remove silicon dioxide also in this process. So we add limestone. Actually, the limestone will be decomposed, will be breakdown into calcium oxide and carbon dioxide. The carbon dioxide here will be used again in this process, this step 2, in the redox reaction. This is also the decomposition is also redox reaction, or we can call it thermal decomposition because it needs heat. And then this one, calcium oxide, remember all oxide of metal is always base oxide, will be neutralized silicon dioxide, which is exit oxide. It will be make slag. This one is called slag. Calcium silicon oxide here. And this slag will be removed from this one. This is, there is pipe here. And the molten iron will be removed from here. That is the process of blast furnace. Okay, that is the reaction. How about if we have bauxite? Bauxite is the name of ore of aluminum. Mainly it contains aluminum oxide. We need to use solvent to dissolve the ore, the bauxite. The name of the solution is cryolite. This is have lower melting point than bauxite itself, so therefore can reduce the cost of the electrolysis, the cost of the electricity, and the cost of heating up of the system. Okay, and then we need to use carbon anodes that need to be replaced continuously. We will explain it after you learn about electrolysis later on. But however, you still need to remember this one. The ore name is bauxite. Aluminum ore name is bauxite. The solvent name is cryolite. Only that one. And the anode is the form of carbon. This is the half reaction, but we will not discuss it now. Okay, we will go to rusting. What is rusting actually? Rusting is the oxidation of iron. This is the oxidation reduction reaction. Rusting itself is oxidation of iron. So it's need oxygen to oxidize the iron, and it's need water. Both is needed. So you can see here oxygen and water. So if one of that one is not present, the reaction will not happen. Okay, so both oxygen and water should be present in the resting process. Yeah, so we have to use air and we need to use water. The tube B, the water is present, but oxygen is not present. If you boil water, it will remove oxygen from the water. And then you seal it with oil, no more oxygen can enter the system. Okay. How about the tube C? Tube C use calcium chloride. Calcium chloride is drying the air. There is air, there is oxygen, but no water. So therefore, no rusting will be performed. Okay. So how you can prevent rusting? The first one, you can use coating by using painting. So therefore, the oxygen cannot reach the iron. And you can use grease. Grease is oil, actually, lipid. So therefore, once again, no oxygen can reach it. And also no water can reach it because water and oil never can be mixed, okay? And then we can use coating with zinc. This is actually a sacrificial protection because zinc, if you can see here, zinc is above the iron in the reactivity series. Yeah. So therefore, zinc is more prone to be oxidized than iron. So therefore, zinc will give the electron into the iron. Yeah. So the iron will not oxidize. That is the sacrificial protection. Zinc is more prone to be positive ion than iron because it's more reactive than iron. Actually, the sacrificial protection is not always using zinc. Sometimes you can use magnesium. Magnesium is above the iron also. So therefore, magnesium is tend to be positive ion, lost electron, and give the electron into the iron. Yeah, that is the sacrificial protection. Okay, prevent the ion to lose the electron to make positive ion. So the iron cannot make positive ion. So if in sacrificial protection, this is Fa. During rusting, iron should make this one, okay, by losing 2 electron. So this one is 2 electron loss, okay, or you can write it here. Sorry, like this one. So you can see this is electron loss, okay. And then because the presence of zinc will make this one, and the electron will be donors into the iron. So therefore, iron will be written into iron will be written into iron. Yeah. So in this sacrificial protection, zinc will produce electron, lost electron, and give it into iron. So therefore, the iron will remain into iron ions like that. Okay. We will go to alloy. Alloy is mixture of a metal with other metal or other element. Can be metal with different size like this one. So therefore, because this one is mix of iron, alloy is mixture. No chemical reaction performed because it's mixture. Okay, but the properties of alloy is usually harder and stronger. Why? Because the composition here you can see, because there is different size, so therefore this the layer cannot longer slide over each other. So you will be difficult to pull it into wire, into the ductility of the iron of the substance. Yeah. So this one, you can see, can no longer slide over each other. It's harder and stronger than the pure metal. And then it's prevent corrosion and rusting. Why? Because some of the metals here will be do sacrificial protection to others. And also, to rust all of the metals here is need energy, need more electron. Yeah. So, for example, brass. Brass is alloy of zinc and copper. The other one is steel. Steel is the mixture of iron with something else. For the example, there is 2 types of steel. Mild steel, which is 99.7% iron, 0.3% carbon left from the blast furnace actually. Okay. The stainless steel is done 70% only iron plus chromium and nickel. Okay. This one, the blast furnace. But the other reaction, this one we have already run, the carbon dioxide. We also can remove sulfur from the iron actually in the blast furnace. But to make steel, to make steel, and this one also we can remove phosphor from it. We can add waste oxide to remove silicon dioxide and phosphor oxide. This is acid oxide also. But in the blast furnace, usually we'll keep little amount of oxygen and carbon here, 0.3% of carbon. Why? It will protect from rusting. Why? because actually carbon has higher reactivity than iron in the reactivity series. So it's time to make carbon dioxide or carbon monoxide than iron oxide. That is us. That is the reason why we keep little amount of carbon here. And we can add other element in the steel actually. Okay, this is logic. Why we will use aluminum to make aircraft? Because it's need to be fly, so you need the density in low density. Okay, sorry. This is logic. Why you need aluminum to make aircraft? Because you need the density low, so it can fly. Why overheat electrical cables is actually the cables that hang up in the roads, like usually if you walk around the complex. Why we use aluminum for make these electrical cables? Because actually it will hang up in the overheat area. It's need low density also. And then also it's ductile, so you can pull it into wire, and also it's also conduct electricity. So the more important one is conduct electricity because electrical cables and low density because it should hang up above. If it high density, it will be sink and your head will be hit by that cables. It's not funny. Why we will use food container, aluminum as food container? Because it's not easily to be corroded. If you remember, aluminum will easily to react with oxygen into aluminum oxide, with which protect it from any reactive reaction. Yeah, so it's not easily to be corroded. How about the copper? Why we will use it into electrical wiring? Yeah, because copper is good conductor of electric and it's very ductile. We can make it into very small wire. Okay, that's all for metal unit. Ani, you can say goodbye. We will come back next week in the state of electrolysis. Bye bye.